Hello everybody and welcome to my channel. Before we start, let me just thank everyone who commented nicely on my last two videos. I really appreciate your words of support. Thank you very much. Also, I would like to give credit where it's due. So I would like to thank Mr. William Faucher for his brilliant tutorials, especially on lighting and rendering. So thank you very much. And what is it we're going to talk about in this video? Many of you ask me questions about lighting, rendering, sequencer, render queue, and so forth. So I try to answer all those questions in this video. So without further ado, let's get going. Okay, so this is my level. As you can tell, it's not just two shots, it's effectively an entire 4K map. And that's because I kind of decided to do a different approach to these videos. I effectively want to create my own film set, my own world. I used Mavi United 3 packs. I bought several packs from them. If I quickly show you, I bought Redwood, Dead Spruce Forest, Conifer Forest, I believe there's one more, Broadleaf Forest, and finally Shrubs and Bushes. So what I did is, I used to have my own landscape material, but because I wanted to utilize every single feature of those packs, I applied Mavi landscape material to my landscape, and it works really well. Okay, next, I use Quixel Megascans, for example, for those big rocks, many of the coastline rocks, for the man-made props like the boat, crate, and barrels. And here I use Quixel Megascans for the base object of this staircase, but I modify it and use PCGs to essentially recreate the entire staircase. Okay, the lamppost is something I modeled in Blender. Okay, the lamp and the rope, they're fully dynamic. So if I delete this one and undelete, it will automatically reconnect. And if I jump into the game, okay, let's talk about water. So what did I use? I use Flux Coastline Domain, Ocean Wave, and Coastline. And then I use brushes to essentially control this tidal wave, this foam. So just to quickly show you, I mean, the original setup was kind of more designed towards oceans, but obviously I needed a river look, so I tweaked a couple of values. And with these brushes, just to quickly show you, I can easily control how much foam and tidal waves I am actually getting here. So let me just quickly demonstrate again. And here you can see it's strong, or you can paint it out completely, like so. Very useful tool. Okay, next, mountains. I created mountains in Gaia and then imported them into Unreal as static mesh and just cloned them around the level to create this mountain range. Okay, sky is ultra dynamic sky. These fog cards, that's EasyFog. And finally, this low-lying fog, this kind of vapor above the water, that's ultra volumetric. So if I click on it again, I should be able to, you know what, I just type in, that's ultra volumetrics. See? Okay, I hope I didn't forget anything. Please have a look into video description. I try to list every single third-party product I use for this video. Okay, and how was it constructed? Pretty much the base path was procedurally generated. So all the trees and grasses are procedurally generated, of course with the exception of my shots, which are handcrafted. So if you combine both techniques, procedure generation for the, say, initial pass, and then you handcraft it to whatever look you desire, I think that's the way to go, at least for me. I really like doing it this way. Okay, let's talk about layers now. So we have lots of predefined layers for our landscapes, but to make them work, you need very strong splat maps. And I did those splat maps in software called Gaia. So this is Gaia 2.0, and the process was I generated terrain here, the height map of it, sent it to Unreal, imported this height map into Unreal Landscape, then I sculpted it more and brought it back here, added more detail, and finally I created splat maps. Every single layer in your landscape material is controlled by these splat maps, at least the initial pass. Then you can of course go and paint everything manually, but the initial pass is done here. So now it covers the entire 4K map. So anywhere I go in the map, I have natural distribution of my layers. So how do I actually bring that splat map into my project? So if you go to Landscape, Import, click Moss, Import. Alright, and now you can see moss is coming through. So the idea is you combine all those splat maps together, and then you come in and paint everything manually where you require. But this will give you very natural base for your landscape. Okay, so now we have to create our trees, and as I mentioned before, I use Procedural Foliage volumes. They were provided by Mavi. They came with the tree packs, so it was very easy to do. But what if you have to start from scratch? What would you do? You need Procedural Foliage Spawner, and you need Static Mesh Foliage. So what is Static Mesh Foliage? Just start with this one. Static Mesh Foliage is essentially a combination of static mesh and set of rules. So how do you create it? So let's just do right click, Foliage, Static Mesh Foliage. And if you open it up, this is where you plug in your static mesh of your tree. So for example, this redwood, just plug it in. Then what's really important is inclusion and exclusion layers. I find it very useful. For example, in this map, I didn't want trees to spawn inside, for example, this water volume. So I painted this area with remove foliage and plug it into exclusion landscape layer. So if I press this plus icon and go to my landscape into paint to essentially see the names of my layers. So one of them is called remove foliage. So I just type it in here. For example, I do not want trees to be spawned on stones. So let's just type in stones here as well. And that's it. Very useful. When you're done with this, you just hit save. And that's it. Close it. Okay, let's go back to my folder and let's create Procedural Foliage Spawner. So again, right click, Foliage, Procedural Foliage Spawner. So if I open it up and you click this plus icon several times, this is where you put your static mesh foliage. Okay, and when you're done, you just hit save and you can bring it into your level. Obviously the scale is too small. Let's just change it to 100. Okay, and that's my volume. Okay, but I'm going to give you real world example and going to essentially regenerate my trees from scratch. So let's just delete this one and go back to my map. Alright, so this is my terrain without trees. So let's generate them again. So these are essentially procedural foliage spawners from Mavi. I kind of modified them slightly and mixed them up as well because I combined several biomes into one. And let me just give you an example. So let's start with rocks, trees. Okay. Now debris. I think it's done. Perfect. Okay, let's resimulate this one. Alright, and we're done. So if I just look around. It looks pretty good. And in theory, anywhere I go, for example, inside here, the woodland should look still absolutely fine, and it does. And that's the kind of beauty of procedurally generated foliage. It's very predictable, it's very fast, very time efficient. Love it. Alright, so what's next? Lighting. So I use Ultra Dynamic Sky plugin, but what if you do not have it? So what would you do? So let me just delete it. Okay, and go to Window, ENV Light Mixer, and create Skylight, Directional Light, Atmosphere, Volumetric Cloud, and Hide Fog. So let's just jump straight into Directional Light and try to roughly replicate the original look. All right. Okay, that's roughly what I would do if I didn't have Ultra Dynamic Sky. But I highly recommend it because it's such a convenient tool and so well documented. So let's just go back to Ultra Dynamic Sky. Okay, so let me just take you through various functions of Ultra Dynamic Sky. Let's just start with time of the day. Okay. The next one will be cloud coverage. By the way, I'm only going to take you through options I like to use. Obviously there's tons of them, but let's just say I find these very useful. Volumetric clouds. I go for full cinematic quality. Okay. I just want the clouds around the peaks. And to achieve that, I change bottom altitude. Okay. And to reinforce this effect, I use 2 layers right here. Sun section I don't usually change, but you can make sun stronger or weaker, up to you. But I prefer to keep my environment as natural as possible. Okay, same goes for skylight, but here I did change one option, which is skylight color. That's because the more clouds you have in the sky, the warmer your indirect lighting is. So watch what will happen if I go back to defaults. It gets a little bit warm, and it's purely my decision to make it slightly colder. Something I prefer. Okay. Okay, the next one is volumetric fog. Let me just switch it on. You can see what it's doing. And if I understand volumetric fog correctly, the further you draw it, the less resolution is in it. So I'm always trying to find right balance between distance and quality. Default value is 8, and I need 26,000 roughly. Okay. The next one I changed is volumetric fog extinction. This one's default. I prefer 0.8, and that's where I left it. Okay, this is your cinematic offline rendering settings. And that's pretty much it. Okay, so the next one we're going to talk about is post-process volume. Very important for your project. So the first one we're going to talk about is bloom. And I usually keep it switched off. All right, the next one is exposure. Very important. And I keep my metering mode in manual. And then I tweak my exposure compensation for each shot. Then local exposure. For example, let's just look at this shot, okay? So if I go to highlight contrast to default setting, which is 1, it will burn my sky essentially. And that's essentially what would happen in real life if you ever tried landscape photography. Many landscape photographers use natural density filters, just kind of obscure the sky with this filter, so you can kind of match exposure for both sky and foreground. And I kind of see this kind of settings in a similar way. Okay, so look what will happen if I change it back to 0.6. Now I have a little more definition in my sky. I could probably go a little further, even maybe 5. And another trick I like to use is detail strength. If I go back to default, it's kind of, let me just find this shot, especially in this shot, I find it kind of is a little bit mushy. But if I increase this value to 1.2, it gets a little bit sharper. Look, 1.2. You kind of get a little more definition in your environment. Alright, so what's next? So the next one is global illumination. So method, lumen. Ray lighting mode is hit lighting for reflections. Quality 2. And max trace distance is, for me, is 200,000. If I go outside this shot, just to kind of show you what it does. If I go to defaults, see what's happening to my reflections. I go back to 200,000. Okay, let's just go back to my shot. Another important setting is final gather quality. I set it to 5. And update speed to 0.5, again for final gather. Okay, the next one is reflections. It's lumen, quality 4, and high quality translucency reflections is on as well. And that's it. And that's pretty much it for my post process. Let's just have a look at our project settings. Okay. So just to make sure we have all the settings correct. So use hardware ray tracing when available, yes. Ray lighting mode, I choose hit lighting for reflections. Detail tracing. And support hardware ray tracing, yes, as well. And generate mesh distance field, yes. Okay. Okay, our environment is ready, so we can start animating cameras. So how do we do that? First of all, we need new sequence. Let's just go to content drawer, find good folder, and right click here, cinematics, level sequence. And that's our sequence. And open it. Okay, so that's our first sequence. So what do we need now? We need camera actors. So let's go to actors, type in Cine and Cine camera actor. Drag it into your level and then press add to sequencer, Cine actor. Okay, that's the one. And now let's build it organized and rename it to Cine camera actor test 1. Okay. So that's our first camera. Now, I would probably start with frame rate. If you want to kind of have more cinematic look to your videos, change it to 24 frames per second. That's what I would recommend. If you want more like a computer game cutscene, then I would go for 30 or 60. And now extend the timeline to maybe 600. Okay. And let's start animating. So if you press this camera icon, that essentially means we're looking through the camera, and let's just put it where we want to. For example, right here. Okay. And go to your transform and press keyframe. Okay. So now we just move our timeline to maybe something like this. Now move your camera. And press keyframe. Now we can actually test what we actually have. Okay. Let's adjust it. So let's move. If you press this icon, it will take you to the first keyframe. Let's just move camera tape forward so it's not cutting through trees. And now we're okay. So what about speed? Speed is okay, but the motion is not linear. It's kind of speeding up and slowing down. So how do we go about it? Well, we can, for example, right click on this keyframe and change it to linear, and same for the second one. And now the motion will be perfectly linear. Okay. So that's our first camera. How do we make the second one? Well, the easiest option is simply Ctrl+C, Ctrl+V. That's our second camera, and drag it into our sequencer. I would like to start my second camera where the first camera ends. So let's just go to transform and click this icon, which will take us to the second keyframe. Right, so. And now we can simply keyframe this transform for the second camera. Let's just move it somewhere else. Okay, because we want this shot to be completely different. So just, for example, be over here. Press new key. Okay, and again, let's just find suitable length, like so, for instance, and move your camera. And press keyframe. Okay, so now we have second camera, and again we would like to have it in a more like linear fashion. So let's just click on our graph editor or curve editor and select all our keyframes and change them to linear, which is this icon here. Okay, and that's it. Now we have two cameras. But what do we do to actually see them both together? Well, they need to be in camera cuts. So first of all, let's just make sure that the first one is correctly adjusted, like so. Then again, let's just press this icon, which will take us to the previous keyframe, and click on second camera actor, press plus, and that's it. Now they're together, and to see them together, all we have to do is just press this camera icon next to camera cuts and have a look. That's our first, that's our second. Okay, and second. Perfect. So now we have both cameras together, and this is where we leave it, and we'll go back to my original level so we can talk more about camera settings. Okay, so let's talk about cameras. The first thing is film back. I usually go for 16:9 DSLR because I'm familiar with DSLR cameras, so it's kind of easier for me to understand relationship between focal length, aperture, shutter speed, and so forth. Okay, next, I usually go for universal zoom to have complete freedom over focal length and aperture. Focus settings is manual, and just to kind of show you what we can do is we can use debug focus plane right here, and it essentially shows you where we're focusing right now. So if I uncheck this tick box and use this tool, I can easily focus on the rock in distance, like so, or back on a crate. Okay. Next, we can talk about focal length. Okay, in this case I went for 80 millimeters and aperture 5.6. This kind of gives me, this combination gives me kind of very nice depth of field and kind of cinematic look to my shot. If you would like to reinforce this depth of field, you can just lower this number, which means you're increasing aperture. So what will happen? So your depth of field is stronger, but at the same time the shot is brighter. And why is that? That's because when you lower this number, your aperture gets bigger, which means more light gets onto camera sensor. Anyway, so to kind of compensate for this, I have post-process settings here, exposure compensation, and I essentially tweak exposure compensation for every single shot to make sure my exposure is correct. So for example, in this case, I can just change this number to something like, okay, maybe a little stronger, 16. Yeah, that's how that feels about right, and that's how I do it. If you would like even stronger depth of field, you can go even down to 1.4. Okay, so let's just delete this and go back to camera 1. And that's pretty much it, really. When I'm building my shots, what's important to me is focal length, aperture. And that's pretty much it. And of course, where you're focusing. So I like long lenses, I like strong depth of field, and quite often I keep the camera quite low to the ground for stronger effect. And that's pretty much it. And now it's time to talk about render settings. So how do we actually render it out? We need to send it into render queue. And to do so, I click this button here and choose my config, because the original config, the plain one, has pretty much nothing inside. So if I show you my modified one, so I have quite a few extra things in. So first of all, I use EXR sequence 16-bit without compression. I still keep JPEG sequence just simply because I want to see previews. Then important section, of course, is anti-aliasing. So the method is none. And spatial and temporal sample count in my case is 1 to 12, but kind of usual one is 1 to 16. Okay. Then I use render warm-up frames because I have lots of landscape grass in my level, and it will most likely crash my engine if I didn't do that. Also, I like to use engine warm-up count to kind of make sure all my grasses and particle effects are fully loaded up before they get actually rendered. Next, color output. I use ACES workflow, and in console variables I used to use loads. But the best quality settings for me is screen percentage. This one really makes a difference. Most of these settings here are just to kind of minimize flicker, which is still in the level, but it's kind of less obvious than it used to be. And the last settings here, grass, color, distance, scale, that's simply because I'm using landscape grasses, and if I want to extend essentially how far they're going to be seen, I need to change this value to from 1 to 5, and just to make sure the whole shot is perfectly covered with grass. Then I'm using game overrides, and finally output settings, which in my case is 4K resolution, 24 frames per second, and say if I need to re-render middle of my sequence, I just specify my custom start frame and end frame, and that's how I do it. And that's pretty much my render queue settings, and then I just hit accept and render local. And for complete transparency, let me just share my DefaultEngine.ini file. Okay. I have to increase nanite budgets because everything in the level is essentially nanites. I did adjust ray tracing culling, but only a little bit. Then, because I'm using primarily virtual textures, I had to increase my streaming pool size slightly. And that's pretty much it. Okay, so thank you very much for sticking around this long, for watching the whole tutorial, and I hope you learned something new, something useful. And if you have any comments or even ideas for future tutorials, please put it down into the comment section. And of course, if you liked it, please like it and consider subscribing, and I see you next time.